Hello guys, this is part 2 of making PCBs. In part 1 we did an overview of how to use KiCad, put the circuit in there and to get it to produce the PCB and to use it for printing out the negatives on overhead film so we can use it to expose the PCB. This is what we're going to do now, and at the end of part 1 we put on the photoresist so it could be drying, and well, it is all ready now to go. I find that making PCBs for prototypes is not very hard. I kind of enjoy the process, and I use less and less of these kind of little circuit boards here where you can sort of solder components on and stuff. And in this case here, when we're working on these buck regulators, they are very critical. The input and the output have to stay separate. There are inductors on there which we have to make sure that they do not interfere with each other by having their magnetic fields interact with each other and all that kind of stuff. So you really have no choice. You got to put it on a PCB straight away and design it right. In any case, everything that we need is here. As I said, it's not really that hard, and I don't think you need that much equipment. Anyway, we have rubber gloves here. They are very important if you're working with chemicals, especially stripper over here. So what I have over here, and I've showed this in previous videos, but to be complete, I need to do that again. This is actually a little frozen meal tray that I like to use because it has two compartments, a little compartment that is big enough for the small PCBs that I work with, and if need be I can put some water in here or put some little tools in there or something to keep them together. I have a little spoon over here that I use to scoop out some of this lye. I have a little brush. I tend to like brushing the chemicals on it because it goes a bit quicker. You don't have to do it that way. You can kind of let it soak, and that's okay too. And I have some of this lye here, which is actually sodium hydroxide, and which is very basic, that I use in order to develop the PCB. Some people use washing soda. That works as well. Apparently, I haven't tried it, but I've seen it on other videos. But then you'd have to use a lot more of it because washing soda, of course, is not as caustic as what sodium hydroxide is. I like to use ferric chloride then for etching. I guess I'm old school. There's traditional. I've seen some people using hydrochloric acid and with a little bit of hydrogen peroxide added. I have not tried that personally, but some people prefer that for some reason. I have some water over here just off to the side that we'll be using. Normally I store the ferric chloride in a little bottle. I will reuse it 3-4 times or more, but at this time, last time when I made a PCB, I kind of felt that it was spent, and we're going to be mixing up some fresh stuff. Now, when the PCB is being developed and we've etched off the copper using ferric chloride, I use this ordinary paint stripper in order to remove the exposed photoresists from the PCB as a final step there. We will also be drilling the little true holes, but the equipment for that we will discuss when we get to that part, because my desk is full. I can't put anything else on there. This here is a 10-watt floodlight. I think it is meant to be for parties or something, like a black light. I don't know, but I wouldn't recommend it because this UV light over here would not be good for your eyes. It says this is I don't know if you can see it, 395 nanometers to 400 nanometers. It's 10 watts. It was relatively cheap. I think I got it on AliExpress. Anyway, everything I have here, with the exception of the paint stripper, I couldn't find it on Amazon or anywhere. I had to go to the hardware store to buy that. But it'll be in the description section. There will be the links there. In some other videos, I showed what I use in order to expose the PCB with the negative on the top. There's a few requirements there. You got to keep the negative flat. You've got to keep the negative flat. Well, if this was the PCB, just let me put it in there. You put the negative on the top, and you would want to keep it flat so that the negative is touching the PCB, so no light can bleed underneath. So I have two little pieces of glass here, which I actually salvaged out of an old picture frame. Some people I have seen actually use picture frames. They put sandwich the whole thing together in the picture frame, and they use that. I find that I want to be able to keep the light about that distance here from the PCB, as you can see over here, and the glass sort of slides in there like so, and I actually have some little magnets over here that I salvaged out of an old tablet that had a little keyboard on it. There were the little magnets that kept the keyboard on the tablet, and this is actually a little cage from an old PC, 3.5-inch hard drive cage that seems to have the right distance from the top there for this particular light here. I put some little Velcro dots on there so that I can put it down, and it'll put it down on there. It'll won't slide off. It'll stick on. You can salvage stuff yourself, or buy things, or make things up if you want to. None of this is all that critical, but this is what I use. And I think that is about all that I can say about it right now until we actually start doing it. So let's go and get things started. Alright, so we are ready to expose the PCB. I have put it in here, and as you can see, the blue photoresist is showing through the negative there, and it is sandwiched between those two pieces of glass. There's little magnets here holding it down, so it's kind of neat. I do like to wear these UV glasses. I don't like getting the UV light in my eyes. Leads to cataracts when you're older, I believe, or something like that. Not healthy. So we can put this light on. We'll be exposing it for 30 seconds only, and as soon as I turn it on, I will stop the video because it is just the ultraviolet light just floods the camera out. And one more thing is, like, if you don't have one of these lights, you could, I guess, try one of these. This is a light that I use for exposing solder mask. It's also 10 watts and might work. I haven't tried it. There's also these little lights you can get for curing resin, and has little. I have not tried it either, but all accounts it should work. Has like little legs on it, so you can actually prop it up like that and put something underneath it, like a little, sandwich like that, just like I've got over there. Potentially, I got this that came with some resin that I bought. And what else is there? Okay, so as I said, we're going to be exposing that for 60 seconds. I got a clock behind me, and I look at the clock until it says, you know, 30 seconds or 00 seconds. That's easy to remember. And then we can actually get it started. So I'm doing that now. And it's like 8 seconds to go, and then I can turn it on. Okay, there we go. I'll pause it now. Okay, that is done. I can put my glasses away. Alright, so now I'm going to get set up for developing. Okay, so I've actually never really measured it out. I normally just throw some water in there and a little spoonful of that lye, but I thought for records I put 100 milliliters water in here, and I got 1.3 grams of lye here, for those of you that insist on wanting to know exact measurements. And again, I have no real recipe for this. I just use what I think might work. Now we'll dissolve it. I'll put some water in this little lid here because it seems to be sticking to it, and I want to get it out. And you know, it's really pretty simple. I mean, if it doesn't develop quick enough, we'll just add another pinch. All right. Now here's our brush, and if all is working well, we should almost immediately after we dump it in there start seeing the circuit emerging. Yep, see, there it is already. You see it? And I just brush it. Very quick, very simple. Now, if you put too much photoresist on there, if it's too thick, it would take longer, and probably you would have to expose it longer. I'm not sure, but that's it. It's done. Cool, huh? Okay, now I will pause the video. I'm going to rinse this off with water, and we'll go to the next step. Okay, so now we are ready for etching. So I got 1 spoonful of ferric chloride here. I'll have to add a bit more, but I'll just start one at a time. I just put it in there until it looks like strong tea, or I put a little bit more water in than what I normally use. This is like 100 milliliters. I just like brushing it on like that. It goes a little bit quicker than if you just let it soak. Now this PCB here is like a phenolic resin or something like that, but in any case it is translucent to light, which is very convenient because once the copper is gone I can hold it up to the light and it will be, I can see when the copper is gone because it'll be translucent, the light will shine through it. I think we're almost done here. Okay. We'll hold it up to the light and see if there's anything. You can kind of see it on the other side already, see? So, yep, we are done. This is it. Okay, so I'm going to clean it off. I'm going to save the ferric chloride for next time. So I'll be back in a minute. Okay, so now we're ready to put the paint stripper on. I could dip it straight in the container since the container is nearly full. And we just paint it on there. And then I'm going to leave it for like 10 minutes or something, and it should be ready to go. It occurred to me that this photoresist is actually quite resistant to everything and strong. I wonder if you could make up a negative with just the solder pads on it and cover the whole thing with this photoresist and actually expose it and make a solder mask that way. Bet you could. Might try that one day. Okay, so let's sit here. I want to stop the camera and come back and see where it is in about 10 minutes. Okay, it's been a little while, and as you can see, the photoresist is coming off, so I'm going to take it and wash it off. Okay, so I have washed off the photoresist and I rubbed it up with a little piece of steel wool so that it is nice and bright and easy to solder when we get to it. So the next job is to drill some of the through holes there, and I'm going to be setting up for that, so we'll get started on that in a minute. Okay, so we are ready to start drilling holes. Now in the past I used this little tool here in order to, if you look at my previous videos too, to drill the holes, which worked okay, but it's not quite as convenient. It has little collets, and every time you change the size of the drills you have to put different collets in there. So, and also, you know, being handheld, it's, you can get vibrations and stuff like that. So I decided I'd make these PCBs often enough that I got something better. So what I have got is, I bought this little drill stand on Amazon, and it seems to be okay, except that I am going to put a little bit of surgery into it. Right now, to adjust the height, you have to use a little hex key, and it's got some cap screws in there. I'm going to make some specialized little bolts there with some levers on it so that I can adjust it without having to use a tool. But that's beside the point. It works. And also I bought this little drill here. I'm not sure how good it is. It can handle small drills up to about 3 millimeters or so, maybe a little bit more. And it comes with a adjustable speed regulator, and what I like about it too is that it has a proper chuck there with a little key, not sort of no collets and things like that, so it's easy to put drills in. So over here I have a smattering of the components, types of components that we're going to be mounting, and most of those are 0.5 millimeter, except the electrolytics are about 0.6 millimeters, and this type of toroid, now I'm still waiting for the toroids to come. I ordered them, but they are still in the mail from AliExpress, but these are some representative sizes. This one has got 0.6, also 0.6 millimeters, but this one here is more 0.8 or 0.9 millimeters, so we're going to drill 1 millimeter holes for the toroids just in case. But I have a 0.6 millimeter drill fitted over here, and I'm going to drill most of the holes with that. The output holes I'm going to drill with a 1.5 millimeter drill over here, so I can put larger wires in there and so on if I need to. Other components, of course, are surface mount, so we don't have to drill holes for that. And the mounting holes here, I'm going to use a 3 millimeter drill for. Okay, so I guess we can get started. I measured it up with these calipers, but I've been using this little ruler as I showed you before. I can check easily the size of the legs. See, this is a 1 millimeter drill, goes into the 1 millimeter hole here, so that's kind of like a nice quick way to check that out. So let's have a look. I guess I might as well change the camera because you can't really see what I'm doing on a big camera anyway. Okay, so this is the holes for the little yeah, fits good. Perfect. All right, just want to double check. Alright, this is it. We've got our drilling done. So now we can actually go and put the components on. And as I said earlier, we designed a PCB so that it thinks that in KiCad it thinks that all the components are at the top. So like this capacitor here would be shown to be like this, but in actual fact it makes no difference if you put it on the other side, as long as you get the negative, this is ground plane here, in the right place. So you can actually put them on this side here, which is what we're going to do, like so, and then we can solder them on this side. And I think yes, this is ground here, so this one would go like that. And this goes over here. This one goes over here. And then we just have some little toroids. This is not the actual one we're going to be using, but it'll be similar. And we have these bypass capacitors like that. So you can see it's sort of coming together like that, and then we will just solder it on the other side, and we should be in business. Okay, so we'll leave it at that. This finishes part 2 of making the PCBs. You could see that it wasn't really all that hard. It certainly was a lot easier to drill the holes with this little drill stand and everything. Normally when you're using the little hand drill, it's hard to center the drill and it might vibrate and so on, and especially for some of those smaller tracks like these guys over here, it had been hard in the past to get those centered, but this time everything seems to be good. Okay, so if you like the videos, we're going to be building this thing and testing it out, of course, in another video. This is going to be the negative voltage buck regulator, and that's as I said, that's for another video. So if you like it, please subscribe and hit the bell thing and like and all that sort of stuff, please. I need another 400 odd subscribers or something. So I will see you guys later. Thanks for watching.